Hello everyone, welcome to our second video in section 7.5. Guess what we're doing? We're going to be solving more trig equations. So quite a few of the problems you'll find in your textbook and also on WAMAP will want you to find all the solutions to a certain trig equation between 0 and 2 pi. So let's look at some examples of that. Okay, so let's say we want to solve the equation. Let's say the sine of 2 theta is equal to 4 cosine of 2 theta. So we want to find all solutions theta between 0 and 2 pi. Go ahead and pause the video and give this a shot on your own before we do it together. Okay, so I think there are two great approaches for this one. One, you might think that, hey, it'd be nice for us to have all sines or all cosines. You might think about squaring both sides. You might square both sides and think to use the Pythagorean identity. However, if we do square both sides, we're going to be worried about extraneous solutions. So if there's a way we can get around that, we might as well try. And specifically what I'm going to notice about this problem is that if we divide both sides by cosine of 2 theta, we're going to get a tan of theta to pop out. So that's a good observation here. I guess if you want, there's a 2 theta here. Or if you want, we could replace that 2 theta with phi. You don't have to do this. Let's say we change this to sine of phi is equal to 4 times the cosine of phi. And instead of squaring both sides and trying to introduce extraneous solutions, how about we divide both sides by cosine? So we'll actually get that we need to solve when is the tangent of phi equal to 4. This is, I think, much simpler to solve. Okay, so what we have here is we're going to have that phi is going to be equal to the tan inverse of 4. Okay, let's notice that this is not a nice number on the unit circle, so we're going to have to use our calculator. So let's think about it here for a moment on the unit circle. Okay, so we have a slope of 4. Here's a slope of 1, so I don't know, maybe here's a slope of 4. So I would say tangent, this angle here, phi, would give us roughly a tangent of 4. Okay. Now, remember that our calculator is actually only going to tell us the answer, the phi, between negative pi over 2 and pi over 2, but there's another solution over here, this larger angle phi, that we'll also need to think about. So we have here, and we have here. Now, I could go ahead and find a decimal approximation for this, but I'm going to kind of hold off on that because we're going to need to do a lot of calculator button pushing. You'll see what I mean here in a second. So here, I know that phi is going to be equal to, well, it's going to be equal to tan inverse of 4. I know I just wrote that down. But this is the one your calculator is going to spit out, but we also need to think about adding multiples of pi to this. So it's going to be tan inverse of 4 plus multiples of pi. Okay, so now what we're going to do is we don't want to solve for phi, we actually want to solve for theta, so let's make that replacement. So what we have here is we have that 2 theta is going to be equal to, 2 theta is going to be equal to or how about I just save ourselves some boardroom. I'm going to replace the phi here with 2 theta. Okay, let's multiply both sides by 1/2. So we'll get that theta will be equal to the tan inverse of 4, all divided by 2, plus, how about we get 2, we're going to get pi over 2k. Meant to put a 2 here. Okay, so we just multiplied both sides by 1/2. Okay, so now what we want to do is we want to find all answers between 0 and 2 pi. So we're just going to start plugging and chugging in our calculator. Okay, so I'm going to type in exactly this. So I'm first going to start out, let's say if k is 0. So if k is equal to 0, I'm just going to type in tan inverse of 4 divided by 2, and just to let you know, I'm in radian mode. So tan inverse of 4 divided by 2, this will be what we get when k is equal to 0. So if we round to to 3 decimal places, we'll get a 0. Theta could be 0.663. Okay. If k is 1, we would just add a pi over 2 to our answer. So we already have our answer in our calculator. So I'm just going to add pi divided by 2. So I just hit, you can hit your answer, this blue answer button. So I hit answer and I added pi over 2 and we're going to go ahead and enter. And it looks like we're going to get 2.234. Okay, if k is 2, so we already added pi over 2 once, so I'm just going to take our answer, just going to hit second answer, so it's taking the previous answer, and I'm just going to add another pi over 2. So we're going to get a 3.805, and we're just going to keep doing it. So if k is equal to 3, we have a 5.375. And you actually don't have to push the second answer button. You could just hit plus, and it's automatically going to pop up that answer button. So let's add another pi divided by 2. And now when k is 4, we're getting a 6.946. But let's see, what, 2 pi? 2 pi is roughly what, 6.28, what is 2 pi? 6.283, roughly. And so this is outside of 0 to 2 pi, so we're not going to include this one. So it looks like we have 4 solutions to this equation between 0 and 2 pi. And here they are. Okay, so the really neat trick for this one was to try to avoid squaring both sides. You know, I didn't want to have to deal with extraneous solutions. Dividing both sides by cosine allowed us a much easier way to solve this problem. Okay, let's do another one. Grab a better marker over here. Okay. I think this is number 28 from your textbook. It's a little bit spicy, so let's do a spicy example. It's spicy in the sense that there's, I don't know, it's a little bit tedious, but let's do it. Okay, I want you to try to solve. So, our next example, let's try and solve a cosecant of 3 theta is equal to 5 times the sine of 3 theta, and I want to find all solutions between 0 and 2 pi. Go ahead and pause the video and give this one a shot on your own before we do it together. Okay, let's do it. So you don't have to do this, but let's go ahead and make the substitution. Let's say 3 theta is equal to phi. So we have cosecant of phi is equal to 5 times the sine of phi. Okay, it's not really, I don't know, it'd be nice if we just had a single trig function here. So using the reciprocal identity on cosecant I think is going to work out nicely for us. So let's say this is, so what is this? This is 1 over the sine of phi will be equal to 5 times the sine of phi. Okay. Let's go ahead and multiply both sides by sine of phi. Let's actually multiply both sides by sine of phi. Let's actually multiply both sides by sine of phi over 5. Over 5. So that way, this way, these will cancel. Kind of just doing 2 steps at once. We're going to get a 1/5 is going to be equal to sine squared of phi. So we can take the square root of both sides. So we have that sine of phi could be equal to the positive square root of 1/5, or we have that sine of phi could be equal to the negative square root of 1/5. Okay, so we'll want to use our calculator for this one. So here we have that phi could be equal to the sine inverse of the square root of 1/5, or phi could be equal to the sine inverse of negative square root of 1/5. Now, before we start kind of like plugging and chugging, I'm actually going to take a look at the unit circle to think about it maybe a cleaner way to write our solution set. So if we take our, maybe I'll draw the picture right here. Okay. We're trying to look for when the height is the square root of 1/5, so some sort of positive number. So let's say it's right here. And the negative, and the negative root 1/5. So let's say that's right here. So we are looking for these locations. Okay. Well, for this one right here, which one is this going to tell? Your calculator is going to tell you which of these four answers. Well, your calculator is going to tell you this angle right here. Okay, so we're going to have that 3 phi is going to be equal to the sine inverse of the square root of 1/5. Now, I'm going to get this one here, but if we add multiples of pi, we'll be jumping back and forth between these two here. So I'm actually going to add, in this case here, pi k. So I'm kind of taking one of the solutions from this piece and adding it over here. So if we divide everything by 3, we're going to get sine inverse of root 1/5 all over 3 plus pi over 3k. Okay. Similarly, if I'm looking right here, we're going to get that. So I should have a theta here. Phi was 3 theta, and I divided everything by 1/3, so here's theta. But theta could also be, 3 theta could be sine inverse of negative square root of 1/5. Okay, well, what that's going to spit out, our calculator is going to spit out this one. So I want to take this answer and I want to add multiples of pi to get to those two locations. So we'll add pi k. And now we can divide everything by 3. And now I have these two formulas here that I just need to start plugging and chugging into our calculator. Okay, so let's do it. Okay, so let's do this first one right here. How about we do this first one here in green? Which ones am I going to get from here? Okay, let's do the sine inverse of the square root of 1/5, close the parenthesis. Let's divide by 3. Okay, so this is what I have typed in my calculator for right now. I'm thinking about the case when k equals 0. We'll go ahead and enter. So the first one I'm getting is a 0.15, rounding to 3 decimal places, 5. Okay, and now I'm just gonna keep adding. I'm gonna keep adding pi over 3. So we're gonna add another pi divided by 3. So then we'll get our second one. So we'll get a 1.202. So that's when k is equal to 2 for this one. So I already have I have these all written down already. So if you plug in k equals 3, you should get 2.249, then 3.296, 4.343, and then 5.391. And if you were to add another multiple of pi over 3, you would be out of the interval from 0 to 2 pi. Okay, but there's more because we've only written down half of them. So now we have to do it with this one. Okay, same exercise. So let's type in the sine inverse of negative the second square root of 1/5. Okay, divide by 3. Okay, so this is what I have typed in my calculator. Okay, let's go ahead and enter. And notice, I'm not surprised that it gave us a negative angle. If you kind of remember that picture, we grabbed, this one was the one that should have reported between negative pi over 2 and pi over 2. So I'm not surprised that this one here was a negative. But the first one we type in, it's not between 0 and 2 pi, so I'm going to ignore that one. So we're just going to add another pi over 3. So we get the first one. So we're going to get a 0.893. Okay, and then you can just keep adding pi over 3. So we'll get a 1.940, a 2.987, a 4.034, then we'll get a 5.081, and let's see, and we have a 6.129. If you added one more pi over 3, we'd be out of the interval from 0 to 2 pi. So here is this long list of the solutions to this equation between 0 and 2 pi. Okay, well, let's hope that most of the exercises that you do in your homework and in WAMAP aren't this tedious, but this is this problem here. Okay, let's do some more. Let's erase what I have here. Okay. Let's try to solve this next problem. Let's say that we want to solve. How about the cosine of 2x minus 1 is equal to the sine squared of x. Okay. This is what we want to solve here. Okay, maybe go ahead and pause the video and give this a shot on your own before we do it together. Okay, so what makes this problem a little bit tricky is notice that we have a 2x here and we have an x here. So the periods aren't matching up. So what we're going to want to do here is we're going to want to make a substitution. So the substitution that we're going to want to make here is going to be for the double angle of cosine of 2x. Now there's 3 versions of this formula, so I think you can make it work with any of them, but let's try to be nice to ourselves. Let's see, cosine of 2x. Well, what are the 3 versions of this? Well, there's cosine squared of x minus sine squared of x. Another version of it is 2 cosine squared of x minus 1, and also a 1 minus 2 sine squared of x. So let's think about which one of these is going to help us the most. Well, it would be really nice if we could have this all in terms of sine squareds. So I'm going to choose to use this version here. So let's replace cosine of 2x. Let's replace cosine of 2x with a 1 minus 2 sine squared of x. So we're making this substitution. Okay, so let's continue to solve this. Really, these parentheses aren't doing anything for us. Just kind of put them there to illustrate we're making a substitution. Okay, so we have a positive 1 here. We have a negative 1 here. So let's go ahead and cancel those out. Okay, so we have a negative 2 sine squared of x is equal to sine squared of x. Okay, so what can we do here? Well, how about we go ahead and add? How about we add 2 sine squared of x to both sides? Okay, So then we're going to get that 0 is going to be equal to 3 sine squared of x. Well, if you want, we could divide both sides by 3. So that'll get rid of this 3. 0 divided by 3 is 0. We could also square root both sides. So that would be equal to the plus or minus root 0. But plus or minus root 0 is just 0. So really this just comes down to us figuring out when sine of x is equal to 0. Okay, so when is sine equal to 0? Okay, you could do sine inverse of both sides if you'd like, but I think it's nicer to think about this. Well, if you did sine inverse of both sides, well, your calculator is only going to tell you this answer, 0 radians, but there's also this answer here. So we could have that x could be equal to, well, we could do 0. You could do 0 plus 2 pi k, and then pi plus 2 pi k, but I think it might just be easier for us to say that x could be equal to, how about pi k? So we get 0, so if k is 0, we'll be at 0. If k is 1, we'll be at pi. And if k is 2, we'd be at 2 pi, 3 pi, 4 pi, 5 pi, so on and so forth. So here is our solution set. Awesome. Now, if the problem asks us to find all solutions between 0 and 2 pi, all the solutions between, let's see, we want to find maybe all x between 0 and 2 pi. Okay, well, what do we record? Well, 0, and pi, and we're not going to include 2 pi. There's a soft bracket here. So you'd either include 0 or 2 pi. We'll record 0. So here are all the solutions between 0 and 2 pi, not including 2 pi. Okay. Let's have you try one of this flavor. Okay. Let's have us try and solve. How about sine of 2x times the cosine of x is equal to sine of x. And I want us to find all the solutions. Let's find all the solutions between 0 and 2 pi. Go ahead and pause the video and give this a shot. Okay, let's do it. Again, the key thing to realize about this problem is here we have a 2x. So we want this to all, really we would like these all to be just x's rather than 2x's. So we need to make a substitution. We need to remember the double angle formula for sine. So sine of 2x is the same thing as 2 sine of x cosine of x. There's only one double angle formula for sine. Okay, so making that substitution, we'll get a 2 sine of x times the cosine of x. Okay, times this extra cosine of x. Okay, so this is where we made the substitution. Is equal to sine of x. Okay, let's see what we got. Okay, these parentheses aren't really doing anything. So we could write this as, how about 2 sine of x? Well, cosine times cosine, we'll get a cosine squared of x will be equal to sine of x. Okay? So let's kind of block this out here. Okay, a mistake that you don't want to make here is divide both sides by sine. You're going to miss a solution. What we're going to want to do here is we're actually going to want to move everything to one side and set it equal to 0. So we're going to have 2 sine of x times cosine squared of x. How about minus sine of x will be equal to 0? Okay, let's go ahead and factor out a sine. So here we'll have that sine of x times 2 cosine squared of x minus 1 will be equal to 0. Okay, So from here, we need to think about sine of x being equal to 0. And over here, let's see, we're going to have that cosine squared will equal to 1/2. Or I hope you can see that we're going to get that, how about cosine squared of x, we'll just write it, will be equal to 1/2. If we square root both sides, we'll get that cosine of x will be equal to the plus or minus square root of 1/2. And this is the same thing as plus or minus the square root of 2 over 2. So this is the square root of 1 over the square root of 2, but if you rationalize the denominator, square root of 2, square root of 2, you should get this right here. Okay, so we have 3 basic trig equations we need to look at. So let's go ahead and solve them. So we have sine of x is equal to 0. We also need to think about cosine of x being equal to the root 2 over 2. And we also have cosine of x equaling negative square root of 2 over 2. Okay, let's go ahead and draw the unit circle. Let's recall we're just looking for solutions. I think between 0 and 2 pi. Okay. Draw our unit circle. Okay, so when is sine 0? When is sine 0? I think sine is 0 here, and sine is 0 also here. So from here, we can get that x will be equal to 0, or we could have x being equal to pi. I'm only recording the ones between 0 and 2 pi. Okay, we have cosine of x would equal to root 2 over 2. Okay. So that's right here. Hope you believe that's at pi over 4. So we have that x could be equal to pi over 4, but this isn't the only one. We also have this location where we have an x coordinate of root 2 over 2. Okay, let's think about what this number here is. Okay, you could say that's negative pi over 4, but we're looking for the solutions between 0 and 2 pi. So we could do, we could just count in increments of pi over 4. So 1, 2, 3, 4, 5, 6, this is 7 pi over 4. Or you could go ahead and take 2 pi and you could subtract pi over 4. So what is this? This is 8 pi over 4 minus pi over 4, which is the same thing as 7 pi over 4. Okay? But we also want the solutions for when the x coordinate is negative root 2 over 2. Okay, I hope you believe this is when the x coordinate is negative root 2 over 2. So what will this be? This will be 1, 2, this will be 3 pi over 4s. And so 1, 2, 3, 4, and 5 pi over 4s. So here we have it. We have found all solutions to this equation between 0 and 2 pi. Okay, let's go ahead and do another example. Okay, let's say that we have the equation cosine of x over 2 is equal to 1 plus the cosine of x. And let's try to find all solutions to this equation, let's say between 0 and 2 pi. Go ahead and pause the video and maybe give this a shot on your own before we do it together. Okay. Key thing to realize here is we have a half angle formula. We got an x over 2, we have an x here, but I guess we have an x over 2, we have an x. We should be reminded that we do have a half angle formula that is going to be really useful for us solving this equation. So let's remember what it is. So cosine of x over 2, that's going to be equal to the plus or minus square root 1/2, and we're going to get a 1 plus cosine of x. If you forget this formula, we have our trusty textbook. Make sure to just look in the back of the textbook, and you can find this. Trig identity here. So let's make that substitution. So here we have the plus or minus the square root of 1/2 times a 1 plus the cosine of x. That's going to be equal to a 1 plus the cosine of x. Okay. So now the big question is, what do we do from here? We need to get rid of this square root. So how do we get rid of square roots? We're going to go ahead and square both sides. Pretty much we have to square both sides. I don't know how else to get rid of this square root. We do need to make a note here that since we're squaring both sides, we might get extraneous solutions. So we got to be careful. But let's see what we're going to get. So whether this is plus or minus, the square will kill it, and it'll also kill the square root. So we'll get a 1/2, and we'll get a 1 plus the cosine of x will be equal to, okay, what are we going to do on this right-hand side? I think it's going to be nice for us to expand this. So if we were to expand this, we'll get a 1 plus a 2 cosine of x. This comes from the O and the I in FOIL, plus a cosine squared of x. Okay, this is looking like an equation that's going to be quadratic in form. Okay, so I guess to clean things up, let's get rid of this this pesky 1/2, and let's multiply both sides by 2. Okay, so if we multiply both sides by 2, we'll get a 1 plus the cosine of x, and that'll be equal to what, a 2 plus a 4 cosine of x plus a 2 cosine squared of x. Okay, so since this is a quadratic, let's move everything to one side. So, and I'm going to rearrange everything. So let's see, we can have 0 will be equal to, well, we have this 2 cosine squared of x. Okay, we got 4 cosine of x, but we're going to subtract 1. So we'll have a 3 cosine of x. We have a 1 here. We're going to subtract it from both sides, so we'll get a plus 1. If you would like, we can make a substitution from here. This is something that's quadratic in form. So we could say, I don't know, we could let y be equal to the cosine of x. You don't have to do this if you don't like to. I think it just makes it look a little nicer. 2y squared plus 3y plus 1. Okay, we need to go ahead and factor this. I mean, you could use the quadratic equation if you'd like, but let's try and factor it by hand. So let's use the AC method. So we'll take the A and the C, we'll multiply them together. So 2 times 1, we get out 2. We need factors of 2 that add to 3, so I think 2 and 1 will work. So here we'll get 0 will be equal to 2y squared. Let's split up the middle term. Plus 2y plus y plus 1. Okay. Let's group the first 2 terms and group the second 2 terms. Looks like in our first set of parentheses we can factor out a 2y. And we'll be left with, what, a y plus 1 plus another y plus 1. And maybe I'll go ahead and keep these parentheses green. Okay, so think that there's kind of a times 1 being multiplied under this y plus 1. We're going to go ahead and factor out that y plus 1. So we'll get a y plus 1 times a 2y plus 1. Okay, let's go ahead and give ourselves some room here. Okay. So looking here, I hope you can see that this is saying that y could be equal to -1, or we could have that y could be equal to -1/2. And we need to remember that y was the cosine of theta. Okay, so let's put that back. So we have to figure out when the cosine of theta, it was a cosine of x. Cosine of x will be equal to -1. and we'll have the cosine of x will be equal to negative 1/2. Okay, you could do the cosine inverse of both sides, but I think it's going to be nicer for us just to take a look at the unit circle. Okay. Okay, so we want to know when cosine is equal to negative 1. Well, the only location where we have an x-coordinate of negative 1 is right here. So one solution between 0 and 2 pi will be x being equal to pi. Okay, we also need to figure out the location where the x-coordinate is negative 1/2. So here's negative 1/2. Okay. So in this case here, our reference angle will be pi over 3. So if we think about it in the first quadrant, that'll be the cosine's 1/2. The cosine is 1/2, and the sine is root 3 over 2. Cosine is negative, sine is positive. So let's see, so we need this angle here. Okay, so what will this angle be? This will be what we could take pi. How about we take pi and we subtract a pi over 3? So what, 3 pi over 3 minus a pi over 3, so we're going to get a 2 pi over 3. So we have x could be equal to 2 pi over 3. Now if you were to use your calculator, this is the one your calculator would tell you, but we have this other solution right here. So to get to that one, how about we do pi plus a pi over 3. So 3 pi over 3 plus a pi over 3, we'll get a 4 pi over 3. And that'll be this location here. So x equaling 4 pi over 3. So these are all the solutions to this between 0 and 2 pi. However, we got to be careful. Why do we have to be careful? Well, remember we squared both sides in the beginning. So we need to check and make sure that all these solutions here work. Okay, so let's do it. Let's check this one. So we have the cosine. Okay, so let's put in a pi. Let's put in a pi because we can keep our unit circle here. Okay, pi over 2 cosine is 0. So 0 will be equal to 1 plus cosine of pi is negative 1. So we get 0 equals 0. This is a good solution. Okay, let's check 2 pi over 3. Let's check 2 pi over 3. If this x over 2 is throwing you off, think about it as a 1/2 times x. Okay, so we're going to go ahead and we're going to replace our x with 2 pi over 3. So we'll go ahead and put a 2 pi over 3. Notice that the 2's cancel each other out. So this will just be the same thing as thinking about cosine of pi over 3. Okay, what's cosine of pi over 3? Cosine of pi over 3 will be 1/2. So we'll get a 1/2 is going to be equal to, okay, over here, we're putting in a 2 pi over 3. Okay, what's cosine of 2 pi over 3? Well, cosine of 2 pi over 3, that's negative. It's going to be negative 1/2. So we'll get a 1 plus a negative 1/2. So we get 1/2 is equal to 1 take away a half is 1/2. So this solution here is also good. Okay, let's check 4 pi over 3. Let's check 4 pi over 3. So we'll put a 4 right here. Put a 4 right here. Okay, so let's see. So this will be the same thing as what the cosine of 2 pi over 3 will be equal to 1 plus the cosine of 4 pi over 3. Cosine of 2 pi over 3 is negative 1. And cosine of 4 pi over 3 is also negative 1. Oh, so here we get that negative, it's not negative 1, it's negative 1/2. And here, this is also negative 1/2. So we have that negative 1/2 is going to be equal to 1 plus a negative 1/2. Well, that's 1/2. Uh-oh, we have a contradiction. Negative 1/2 is not the same as 1/2. So this is not a good solution. Okay, so we only have two solutions to this equation between 0 and 2 pi. That's x equals to pi, and x equal to 2 pi over 3. And here are our solutions to this equation between 0 and 2 pi. let's do one more. Let's do kind of one more flavor of problem that you might see. Go ahead and erase what I have here. Okay, so I just want to show you some problems that kind of have some tricky factoring to them. So let's say we have 4 times the sine of theta times the cosine of theta plus 2 sine of theta minus a 2 cosine of theta minus 1 being equal to 0. Go ahead and pause the video and see if you can solve this equation here on your own. Okay, let's do it. Well, I see a lot of sines, I see a lot of cosines. I don't know if really squaring both sides sounds like something we really want to do. Well, something to notice about this problem is there are 4 terms, 1, 2, 3, 4. So maybe we could try factoring this by grouping. So let's group the first 2 terms together, and let's group the second 2 terms together. Okay. Well, what can we factor out of the first set? Looks like we can factor out a 2 and a sine of theta. Okay. And what we'll be left with? We'll be left with, looks like, we'll be left with a 2 cosine of theta, 2 cosine of theta plus 1. And look, we can factor out a negative. We'll factor out a negative, and we'll just be left with a 2 cosine of theta. Looks like plus 1. Okay. What's great is that what's inside the green parentheses match, so we can factor that out front. Think of there as kind of like a times 1 here. So factoring out the green, we'll have a 2 cosine of theta plus 1, okay, times, looks like we'll have a 2 sine of theta minus 1 being equal to 0. Okay, so we have the 0 product property, either this is 0 or this is 0. So here, we could have that the cosine of theta could be equal to what? Negative 1/2. Over here, it looks like we could get that the sine of theta could be equal to positive 1/2. Okay, these are nice numbers on the unit circle. Again, you could take the cosine inverse or the sine inverse of both sides, but we just use the unit circle. Okay, so let's do this one first. I want to know when the x-coordinate is negative 1/2. Negative 1/2. Okay. So I think this is when theta will be equal to, this is 2 pi over 3 plus 2 pi k. Here we're finding all the solutions. And theta, I think this one here is 4 pi over 3 plus 2 pi k. I guess you could do, for this one, you could do 2 pi over 3. You could also do negative 2 pi over 3. So if you want, you could say plus or minus 2 pi over 3 plus 2 pi k. If you want to condense your solutions. Maybe for right now, I'll just kind of leave it how it is. Okay, what about when sine is equal to 1/2? So that's when the height is 1/2. That's when the height is 1/2. So we need these 2 locations. Okay. Well, this one here, will that be? This will be when theta is equal to, what is this going to be? That's when the y coordinate is 1/2. That's going to be pi over 6. So we'll get pi over 6 plus 2 pi k. Or we could also get theta being equal to, I think this will be 5 pi over k. 5 pi over 6. 5 pi over 6 plus 2 pi k. So here are our solutions. Okay. So this one just took a little bit of tricky factoring, but how fun. Okay, that's all I have for you for solving trig equations. We're going to kind of be jumping gears in the next section. We're going to start learning about a new coordinate system. We're going to start learning about polar coordinates. We'll see you there. Take care.